So I'm Donna McGregor. I'm new faculty at Lehman, and Madeline and I have actually never met before, so this is our first time doing that. But before I start, I just want to point out, I have to apologize because I was under the impression I would be able to use my Mac. And upon arriving, they told me we can't record you unless you use the PC, which means we're going to have some weird spacing on the screen, so just bear with me. Right? So a colleague of mine, Pam Mills, and I started thinking about flipping chemistry about 3 years ago while we were at Hunter College. And so what I want to do today is talk to you a little bit about where we are now and how we got to where we are. And so the big question people always ask us is, why would you have thought of flipping a class like chemistry? And the reality for me is there were lots of reasons, but the one that we think is most important is thinking about educational attainment. And so if you look at the graph on the screen, the three different colors are showing you on a time scale starting from 1940 through 2013 the kinds of degrees that people have earned. And if you look at it, you'll see that more and more people are starting to earn a college degree, right, a bachelor's degree. And no longer are people just getting through with not even getting through high school, right? You have to get through high school, you have to earn a college degree. But what this means is our classes are growing. But what's even more striking is if you look at poverty rates as a function of educational attainment, then what you see is that the early boomers, right, these people, if they graduated from high school, were only 7% at risk of being in poverty, which means if you got through high school, you were going to get a job and you were going to be able to think of yourself as making it. But the millennials, where I just make it into that category, we in 2013, even with the college degree, we're still at a 6% risk. So now, with the college degree, we are almost as much at risk of not getting a job and being able to make it as people were before with just getting through high school. And so what this means is getting a high school degree is not only something that more students are doing, but it's essential to trying to make it out in the world. And so the problem arose, which was, how do you teach to this? So, you know, I taught at Hunter a class of 1,000 students in chemistry, in Gen Chem. So this isn't my Hunter classroom, but this is what it looked like. And so you're faced with two huge challenges here. One is you want all these students to walk away with a content, right? So chemistry is a content-heavy course, and so how are you going to achieve that? And the second thing is you also want to prepare them so that when they get out of your course and graduate, they can go into the workforce with the skills they need, which today are not content-based, right? So what do? And so Pam and I sat down and started talking about what students need today. And what they need is what's called 21st century skills. And so back in 2012, right, the NRC published this report where what they said is 21st century skills have been around forever, right? The idea of a set of skills that people need to make it. But what's changed is that we now require students to attain mastery across multiple domains. And in the landscape of today, this means they have to attain this mastery across multiple levels of technology, and they have to be able to process information, and they have to be able to do it well. So our task has changed. It isn't just how do I teach to the masses, it's how do I infuse 21st century skills into my class while recognizing that at a place like CUNY, there's a huge diversity in my student body. At Hunter, we have lots and lots of Macaulay Honors students, and they're in the top 2 percentile in the country. And then we've also got a huge number of students who come from low-performing high schools, high-need students who don't have the support that those very high-performing students have. And so what we wanted to do is figure out how to do this. So we started this project at Hunter, which, if you know CUNY, this is one of the elite CUNY schools, right? It's got a largely white Asian population, services largely students from Brooklyn and Queens. Many of the students come from high-performing high schools, a large post-bac population here, which really raises the standard of performance. And then look at Lehman College, which is not one of the high-performing CUNY schools. Lehman is, in fact, often thought of as the worst science school in CUNY, right? The sciences at Lehman are not thriving. We service students from the Bronx. We service a lot of low-performing students. And so can we take a flipped model and make it work here with your high-performing students, which everyone says absolutely, and here? with your students who aren't doing so well in a different kind of demographic. And so what we did is we said, if we're going to do this, we have to think about what students learn. So there's these 3 domains of competence that, if you know anything about ed literature, people rely on. And the idea is we got to teach them to problem solve and think. But at the same time, they got to be able to self-regulate, right? That's one of the most important interpersonal skills. And then they have to be able to communicate. And if we really want to infuse these skills and help students learn, we have to do all 3 of these things simultaneously, where we really want to build the metacognitive side of student learning, and at the same time we want them to have transferable knowledge, where they can take what they've learned and communicate it about it in a way that is effective and will help them to become successful. And so everything we do is about trying to make the students think about what they're learning, reflect on what they're learning, communicate what they're learning in all 3 of those domains across our course, right? And so what we've done is we've designed our flipped course so that there are 2 essential components, where we've got a set of resources that's about teaching students content and building into the metacognitive. And then we've got these things called soft skills that we think are absolutely essential to make it, which is students have to learn how to self-regulate, organize their time, collaborate with other people, and engage with both their peers and the community about what they're learning. And so what is it that we have, where did we start, right? I think anyone who's taught at any time, including myself, who, you know, my PhD is in chemistry and I did a component of chem ed. So I came into this thinking about how students learn, but I started here, right? We all start here, which is you do this very traditional, you walk in, you talk to them, they buy a textbook, they do their homework, they take an exam. Where I am now with Pam Mills and some other colleagues is thinking about this flipped model where if you look at this, students still get a syllabus and they still take exams. But how we help them prepare is very different. And so I'm going to challenge Madeline here, who said you don't need video. In a course that is content heavy, video is essential. And more so, your video has to flow, right? What you cannot do, and I'll talk about again later, is cobble together random videos from the internet and then expect students to feel like you're giving them a coherent course. It doesn't work in a flipped model. And so what we did is we created videos. We've created 195 videos for Gen Chem 2 semesters, right? It's an astronomical amount of work, but it's been worth it. Students still take notes, but they take the notes from the videos. In the videos are something called Let's Practice questions, and they no longer buy a textbook. They buy the Let's Practice workbook, an iClicker to do interactive in-class problem solving, access to an online homework platform. We're using something called Sapling, which I think is the best one that I've seen out of everything that's out there. And then a workshop session where they do small group problem solving, where they can solve longer, more cognitively heavy type problems than what you would generally do in a multiple choice iClicker session. That's not to say multiple choice cannot test higher order cognitive thinking. I believe it can. I've been doing it for about 6 years now, and if you really take the time to do it, it can be incredibly powerful. So again, everything we do is about student engagement. This is a workshop session at Hunter where you can see the students are in small groups and they're problem solving with one another. There's a teaching assistant in the room, Yannick, and then the students walk around, ask questions. Once you've done it as a student, you start helping other students, and that process of helping also improves your own learning because you're communicating about what you've done. And so what have we done over time? And so I'll put everything up here and spend not more than a minute on this. In 2013, we decided if we were going to do this, we needed to flip our sequence, and we needed to see if it worked. So we flipped 3 modules, not everything. And one of the modules we flipped was the mole. So we did a video segment on what is the mole, and then I never taught it. Then we did stoichiometry. So if the kids don't get that, they can't do everything else, right? So it was a sort of a proof of concept. In 2014, we ran a pilot flipped Gen Chem course for what we wanted to be 80 students, but we had 250 students sign up and want to do it, so we opened it up and we took all 250. In the fall of that year, we ran 2 fully flipped Gen Chem courses for 1,200 students, a section of 1,000 and a section of 200, a day class and a weekend class, 2 instructors. This year, Pam and I have moved to Lehman. We're now running 3 sections of fully flipped Gen Chem 1. At Hunter, we have 275 students with a Hunter instructor. And at Lehman, we have a day class and a night class of 100 students and 30 students. And then Gen Chem 2, we're running 3 fully flipped sections of Gen Chem 2, where for this, we were creating videos during this semester. We recorded the last videos last week, Wednesday, right? So we were a week ahead of the kids with getting the videos ready for Gen Chem 2. And I'll show you later. We weren't planning to do this, but the student body revolted and wanted it. They voted 98% for the hybrid in Gen Chem 2 after the hybrid in Gen Chem 1, so we made the videos, right? And here again, it's 3 sections, 2 different institutions, 3 different instructors teaching the course. And so I said we started by flipping our sequence. Pam and I believe very much that a course like chemistry has to be taught in a way that we think of as a learning logic, right? What is the best way to learn? It's not necessarily historical, and it's not necessarily the order that's in the textbooks. And so we've got a semi-atoms first approach for Gen Chem 1, and then we build on this learning as we go through to Gen Chem 2. And so here you'll see there's 91 videos that make up the Gen Chem 1 course. The videos range in time from 3 minutes to a max of 10 minutes, although some of our Gen Chem 2 videos, being this was round 1, about 12 minutes long, and so we need to think about how we're going to cut those up as we edit those later. You know, the videos, again, I think they're essential. They are the backbone for the course, and I haven't delivered a single lecture since the beginning of 2014. None, 0, zip. Right? It's all going to the students through the videos, which means those videos really matter. And so we found that having a consistent theme for all the videos is important. Last summer, we hired a team of artists. We had a little grant, and we spent $35,000 on developing artwork and animations for the videos that fit with what we want to do. This isn't something I think everyone has to do to develop a flipped course, but part of what we wanted to do with these videos is if we can get them to be good enough, we can give them to people who are struggling to teach chemistry and say, use this and try this, instead of walking into the room and trying to make it as an instructor and trying to help your students learn. So there were 2 critical components here. One was the voice on the video. We didn't want to male. We wanted to move away from the stereotypical you know, old white male is what teaches chemistry. Turns out at the end of the day, it's my voice on the videos. People, you know, we did a survey of things, and the students seemed to like the voice. I think it's the accent more than anything else. So that worked well, but it meant I needed to think about how I did the videos. There's a lot of research that says if you're going to teach through videos, your video has to be paced at the same rate you talk. That doesn't work. It's too fast. They can't keep up. They can't take notes. We had to slow it down. So I talk slowly, deliberately, articulate everything, and try and be as clear as I can. The other thing was that it has to be clear, right? When you're talking to the students, the one example you choose to use in your video has to be the one example, because unlike class, you aren't going to do 6. You're going to do 1. And they're going to watch that 1 as many times as they need to get what you're trying to say to them. And then we realized that there needs to be guided practice in the videos as well. So the students watch the video, and at the end of every video, there are let's practice questions. So this is an example from topic 1, video B, right in the beginning, right? Phases of matter, very easy question. But the Let's Practice workbook contains every single question that's in the videos, presented as it is on the screen in front of them, so the student has a place to write their answers. So the video will say to the student, pause the video here and do whatever you need to do, and then 3 seconds later the video will continue with here's the solution and an explanation of how you get there. So students have to self-regulate here. They have to choose to stop and solve the problem instead of just watching it through. And what we found is that the workbook is engaging them and forcing them to do that. So the students who buy the workbook, this is optional, have reported that they're 90% more likely to stop and do the problems if they're going to do them in the workbook versus whatever scrap of paper they can find and use during the course of the day. The next thing that was important is, you know, are the students using the videos? And so because we're using the iClicker, it's a very powerful way to collect student data anonymously in the classroom. And so I do surveys with my class routinely. This is a survey from Hunter, so this is responses from 1,000 students. And so the first question is, what's your primary source for information? Are they using the videos, or are they finding that they're going to a textbook or some other resource? And we find that 76% are using the videos as their primary resource. So that was the first thing that told us this is good, because they're not discarding the videos and going to other places to get what they need. The next thing was, how are they using the videos? And here what we're finding is that, again, 70% are saying that they watch the videos and stop and pause often and take notes, because that's essential, right? My current class is doing better here than this class at Hunter was. I've spent more time talking to them about the importance of taking notes from a video. And so here I was at about 85% in my Lehman class this year with students taking notes. The next question was the content in the videos, right? So I'll preface this with something I'm not showing, which is we surveyed the students about how do you find the content in the videos. It was too simplistic, right on track, or too difficult. And most of our students said too simplistic, which we found interesting. And then in having a discussion with them, we started to think, okay, they're confusing simplistic with clear. As soon as something is clear, they say it's simplistic. So we gave a follow-up question, which was, how do you find the content? And it was all based on, is it clear and is it comprehensive? And then, are you using outside resources? And so these are the statistics from this year, the Hunter course and the 2 Lehman courses. And what's really important, I think, is we don't actually want them here in A. Because if they're going to learn to use information and get better, they should be using other resources to help themselves get better. So when these statistics came up, we all stopped and said, look, if you're here in A and you're not getting an A in the course, this is why. Right? You need to be using more stuff than just the videos that we give you to learn. And so we want them to be here in B and C, and that's where most of our students are. And for Pam and I, we've done 3 iterations of the videos for Gen Chem 1, so we want to not have any of this, right? Not clear and not comprehensive, because then it means that our videos aren't working. The other thing that I want to just talk about briefly is the clicker class. So this is what the iClicker looks like. The idea is students come in and we do what we call peer instruction. This is based a little bit on the work of Eric Majeur at Harvard, who started doing this 10 years ago in his physics classes. And this is in the clicker class. Again, this is a picture at Hunter. Hannah is one of our teaching assistants. In the Hunter clicker class, I had 8 teaching assistants with me in a room of 1,000 students. At Lehman, I have 1 student with me in the day class, and I'm alone in the night class. I've only got 30 kids. At Hunter, in the 275 class, Gabby has 2 teaching assistants with her. So we try to have a person per every 100 students in the big classes so that there's someone for them to talk to. When the students come in, we solve problems. That's all we do. We solve problems of various levels. So every problem that the students solve has 3 tags on the top. The first tells them the complexity of the question. Level 1 and 2, that's what it takes to pass the course. Level 3, that's what it takes to get an A. Level 4, that's what it takes if you want to get 100. Right? So the students can start recognizing difficulty. The second tag is the topic that we're in, just so that it's linked to them later so they know what they're doing. And the last thing is the learning goal. Every topic has a set of learning goals, and we're linking the questions so that the students can start developing the skills of, when I read the learning goal, what are the kinds of questions you might ask me on that? Because we hand out learning goals and we think students get it. They don't have a clue, right? They read the learning goals, but they've got no idea how you might test them on those learning goals. So we're trying to build that into the course here. On average, in a 2-hour clicker class, we do between 12 and 14 questions. Students need to get 8 to 10 questions right, and then they earn 11 points for the day. So every clicker session is worth 11 points. You can get 4 wrong, but you got to get the others right in order to earn your points. And I think what's important here is you don't only get 1 shot, right? There's some questions where we let the class do it, and you can design questions like this. You look at the distribution, and it's 50% A, 50% B. Perfect. It's exactly what you want. Then you stop and you say, okay, you all know that it's not C or D. Now go and sort it out. And then they talk to one another about why they voted for what they voted, and they start having to defend, and then they coalesce on the right answer, right? And that is the perfect kind of clicker question. And so we talked to the students about the clicker sessions. We found early on in the semester, 78% say the clicker sessions help them learn, albeit they don't all enjoy them, right? Some of them find it a little stressful or they don't want to do it, but it helps them learn. And later on, we asked them, why are the clicker sessions helpful in a separate session? And this was interesting because here we were asking, are they helpful? And here we were giving them reasons for why they might be helpful. 89% find them helpful, but only 78% find them helpful when you ask the word helpful, which again, they don't know what helpful means, right? So you have to break it down and give them things to think about. The next important thing is, what do students do, right, in a clicker class? And so our student week looks as follows. On a Tuesday, the students have to have watched the videos. They earn points for watching the videos. So by Tuesday, you have to have logged in and watched all of the videos. You earn your video points. Sometime during the week, you're going to have a workshop, and sometime during the week, you're going to have a clicker class. I say sometime because in a class of 1,000, there are workshops all day, every day from Monday through Friday. So your workshop could be any day of the week. If you haven't watched the videos, you're going to have a really hard time here. So you've got to watch them. The workshops are graded by the TA, and each one is worth 10 points. Sometime in the week, you're going to have clicker class. Again, if you've done nothing, you can't succeed in that clicker class. Clicker class is worth 11 points. Every Friday, you have to do your skills practice homework. Where am I on time? Okay, skills practice homework is linked to a video. So every video has a skills practice assignment. There are 3 questions based only on that video. And then by Sunday, you have to do your synthesis homework, which is where we get to take all the content from all the videos and mix it together in more difficult problems. So Friday, just the skills individually. By Sunday, you gotta have got it together for that week. And then homework closes. Everything closes. Monday morning comes, you start a new topic. So students keep organized using a custom website that we built. They can see their upcoming assignments, they can see their progress, and on a weekly basis, they get to see their grade in the course. So if class ended today, this is the grade you would earn, an A, B, or C, whatever it is. So the student knows where they stand all the time. Now, the biggest thing is, does it work? So at Hunter, over 10 years, this is what a traditional lecture looked like. 12% withdrawal rate, 60% passing rates. In our hybrid right now, this is what we look like. 944 students in a class on average, mix of different instructors doing it, 5% withdrawal rate. The kids are staying in the class, and an 84% pass rate. I think what's important to mention is we didn't just go from here to here. In between, we developed what we call an engaged lecture. We brought clickers into the classroom, we started doing workshops, we had that middle ground, and our goal here was to match this, not to beat it, to match this, and we did. So we were incredibly happy with that. The next question is, oh, this is what I wanted to show you. So this is, we polled the students about what they want in the spring. It became apparent that Pam and I were leaving Hunter, so we told the students, look, we won't be here next semester. And then the students went into revolt, they went to complain, they don't want to, do a traditional, how are they going to survive? So we said, okay, do you want the flipped classroom? And what we found is that 96% of the students wanted videos. If you look here at C, it's very interesting. They wanted videos and lecture. On top of everything they were doing, they also wanted more from the instructor. So we took this to mean I want flipped, right? Not I want traditional. And so at the end of the day, we went ahead this spring, and we were a week ahead of the students making the videos for Gen Chem 2. The next thing is, can it work across campuses, right? So student satisfaction is one thing, big picture statistics are one thing, but if you look at 2 different student demographics, what do you see? So this is our first exam. This is the Hunter students, and this is the Lehman students. And as you would expect, the Hunter students are doing better than the Lehman students. Now, 5% is one question on the exam. It's not a big deal, right? It's one exam question that makes the difference between these 2 groups of students. But Lehman has a bigger bottom end, right? What's very interesting is if we take out that very bottom group, the Hunter percentage changes to 78, and the Lehman average changes to 77.6. Without that bottom end, these 2 cohorts look exactly the same. So now what did we do? At Lehman, I now said, okay, now that I know these students, we've had one exam, and I see what the distribution looks like, it's my job to work with them in my in-class time and get them to think differently about their learning, right? So after this exam, we posted for both groups of students. We're sharing the same website. So the Hunter students and the Lehman students log on to the same platform, do the same videos, same exams. I write the exam with that instructor together, and we post statistics together. We post for them an average of both. They didn't see 77 and 72. They saw 75 or whatever it was, right? And so both groups of students, you did phenomenally. This is great. Well done. Keep going. And then we got to exam 2, where these are our statistics. So the Lehman students on exam 2 outperformed the Hunter students. This is nothing. I mean, statistically, this is insignificant, right? But I showed the Lehman students these statistics, and I said to them, I don't want to hear it again. I don't want you to tell me I'm not smart enough to do this. The Hunter kids are so good. Worse, we have to take this to the Lehman administration. Because when we started, I got asked during my interview at Lehman, well, when this fails, will you be willing to go back to the traditional? Right? And so what I said to them was, I said, look, if this fails, I'm willing to figure out what I need to do to make it work. It clearly isn't the traditional, right? So even the administration didn't believe that the students could do it in this model. They all said they won't watch the videos. They won't do the homework. But the reality is the students learn very quickly that if they want to succeed, they've got to be able to do the work. And if they want to be able to do the work during the problem-solving sessions, they've got to know the content coming in. So as a last comment, I'll just say, in the beginning, the Sapling homework is designed so that every now and then it stretches the students, right? I taught you 1 and 1 is 2. I taught you 2 and 1 is, what? 2 and 1 is 3. Now what is 3 and 2, right? So in the beginning they complained, all of them. It's unfair, you didn't teach us this, how are we supposed to do this? So we talked to them, use outside resources. Now, the students in Lehman, they come every Tuesday, it's an open day. Hunter has the same, every Tuesday is an open day. The students come into a room and they work problems. Now they put a problem on the board and they say, oh, this is one of those ones that I have to stretch myself, right? I say yes. And I sit on the desk and I watch them. And they help one another. At the end of last week's session, I was writing a grant during this office hours session. The students said, oh, thank you for being here. I said, I didn't do anything. I sat at the desk for 3 hours and you helped one another. They said, oh, but you were here if we needed you. Right? So the point is they've become self-driven learners. They've become the kinds of learners who recognize they need to stretch themselves, who are learning how to use multiple sources of information in order to engage themselves in learning and care about making it at the end of the day. So the last slide that I'll put up is just, I mean, if there are any faculty in the room who are interested, we have just gotten a CUNY Advanced grant where we're going to try and do faculty development for flipped classes. So if people are interested, contact me, and from June 1st to July 1st, in our live chemistry class for Chem 2, we want to bring in faculty and show you how to use the model and then work with you once a week to think about how to adapt it to your classroom so that you can try and see the same sorts of results that we are seeing. And then with that, I'll close and say thank you all for your time. And if you have any questions, I'm happy to answer.